Hello, welcome. Let's continue with our tutorial on polynomial function and factor theorem. So we are saying that if 6 minus x squared is a factor of a given polynomial f of x, which is mx cubed plus 5x squared plus kx minus 18. We have to find the values of m and k in the given polynomial. We deal with the factor theorem, saying that if a particular linear function is a factor of a polynomial, then it means that the zeros of that linear function will also be the zeros of the polynomial. So what it means is that if I have k, which is x minus c, if this is a factor of a given polynomial f of x, that simply means that the zeros of this, which is x minus c equals to 0, making x equal to c, will mean that f of c should also give us what? 0. So we are going to use this principle in order to find the values of k and m. But in this question, we can see that our divisor is not a linear function. It's a quadratic equation or a quadratic expression. So what do? We also take the fact that if ax squared plus bx plus c is a factor of a given polynomial, then it also means that x plus a or x plus b will also be a factor. That is, if I factorize this to produce these two linear terms, if the quadratic is a factor of the given polynomial, then it means that these individual linear functions, which are the factorization of the quadratic, will also be what? A factor of the same polynomial. We know in a quadratic, we always like to get the x to the power 2, the term or the coefficient, to be always what? Positive. So I can rewrite this multiplying through by a negative number, which will change this to become x squared plus x minus what? 6. Then I can easily factorize this, looking for the factors of negative 6. When add, I'll get a positive 1. And I believe those factors are going to be in these two brackets. The first will be x. The factors of this could be negative 2 and 3. Could be positive 2 and negative 3. If I multiply, I'll get back my negative 6, but their sum to give me 1 as a coefficient here. And that could only be negative 2, 3. Meaning here I have negative 2 plus what? 3. So since we are saying that the quadratic is a factor of the polynomial, then it means that each factor, that is its factorization, the x minus 2, x plus 2, will also be a factor of the same polynomial. So in continuation, we say that taking the first one, for x minus 2 to be a factor, what do? We find the zeros of this by setting this equals to 0, which implies that your x is going to be what? 2. And following the factor theorem is going to be f of 2 should give us what? 0. If this is the factor of the polynomial, then it means that if the zeros, which is the 2, replace x, I should get the whole expression to become what? 0. So what do? Our f of 2 is going to be x is replaced with 2 to the power 3, 5. Your x is going to be replaced with what? 2 squared, k2 minus what? 18. Replacing the x in the polynomial with the 2. So I believe in this I'll have 8. So 8m, this will be 4. 4 times 5 will give us 20. This will be 2k minus 18. We are still having constant, so we can operate that. Don't forget, we are saying this expressions will be equal to 0. So let's include that. So I can have my m with each coefficient plus 2k. I believe if I put the two together, it's going to be 20 minus 18. That will be plus 2. That will give me what? 0. So I can see this will be an equation where the two will cross. But before the two cross, I can see a common factor of 2, 2, 2. So this becomes 4m plus k equals what? Minus 1. As in dividing through by what? 2, which is the common factor. Then for the second one is also a factor. So this will imply that your x will be equal to negative 3. Then f of negative 3 should also give us what? 0. Since it's a factor. Good. So in the same expression, our f of negative 3 should be m negative 3 all to the power 3, 5 negative 3 squared, k negative 3 minus what? 18. All this must give us what? 0. We should get 0 since we are following this. So the whole of this is what we are having here. So let me just leave this here. So the whole of this is our f of negative 3 equals to a 0. I believe you know that since we are having a negative number raised to the power 3, our answer will still be negative. So 3 exponent 3 is 27. So negative 27. Negative 27, m will come. A negative square will be positive. So 3 square will be 9. 9 times 5 will give us what? 45. Positive. Then we have negative 3k. Then we can send our 18 to be what? A positive what? 18. Since it's negative, crossing to become positive. In this also, I can see a common factor. 3 can go in all of them. So I'll be having 3 here, negative 9m, 3 here. I'll also have what? 15 minus k equals to 6 if 3 goes there. I can see this a constant. Let me cross it. Negative 9m, k equals to 6 minus what? 15. Repeating this, finding the values of this, I believe this will give us negative 9. So that becomes equation 2. We have equation 1, a variable of mk, equation 2, mk. So solving the two equations simultaneously. So in solving the two equations simultaneously simply means that I am going to compare equation 1, equation 2. Elimination could be easy because I can see the coefficient here is 1 positive, 1 negative. So if I add equation 1 and 2, I will get rid of my k. So equation 1 plus equation 2 give us 4 plus negative 9. That will be negative 5. So negative 5m, k plus negative k is far away. So minus 1 plus minus 9. And that will be minus what? 10. So I believe I'm looking for m. So divide both sides by 5. Negative 5m, negative 5, negative 10, negative 5. So m in this case is just going to be a positive 2. So if m is positive 2, I can employ equation 1 or 2 to find the k. So put m equals to 2 into equation 1, which is going to be 4m, which is now 2, plus k equals to minus 1. I believe this right here will give us 8 plus k equals to negative 1. Maintaining the k, sending this will give us k equals to minus 1 minus 8, where I'll have my k equals to a negative 9. Therefore, so we can say that therefore the values of k and m that we are looking for is nothing but 2 and -9 respectively in terms of the m and the k. So we can see that we say that under factor theorem, we normally use a linear function in dividing. But when the case shifts from linear function to a quadratic, we can still perform our division or still perform our operations. So these are the steps we follow when two unknown variables are presented in a linear, in a polynomial. These are the procedure. Thank you so much for watching. If you do appreciate this video, like, share and comment. Don't forget to subscribe if you are new to the channel. Bye bye.